All right, going on now to example number 8. Another really cool, awesome real-life example. So the path of a baseball. So let's go and read this and see if we can make some sense of this. Tamale with sprinkle little trees on there and some pasal. All right, a baseball is hit at 3 feet above the ground at a velocity of 100 feet per second. So that means it's traveling at 100 feet per second at an angle of 45 degrees. The path of ball is given by the function, this weird looking thing, where x and f of x are measured in feet. So the ball's hit. Will the baseball clear a 10-foot fence located 300 feet from home plates? Oh, this is kind of cool right here. So we're talking about the dude who's up the bats. Once again, please do not think that I know what I'm talking about as far as baseball or anything like that, or even drawing here. But okay, so here's his bat right here. Okay, no laughing. Hey, no laughing. Okay, so that's his thing, and he's gonna hit a ball right here, and it's gonna go. Right? I mean, usually it travels in that kind of fashion, right? Like it goes up, then it goes down. They want to know if you are 300 feet away, is it going to clear this wall if the wall right here is 10 feet? Okay, that's the question. Is that will it clear it, or will it do something like this and go, and then it's just going to, kind of bounce down? So that's the question right there. Okay, so can we have like a little picture there, and we know what's going on? Okay, and so they give us some cool stuff here. They give us that the feet, that they tell us that, okay, so this is 3 feet above the ground right here, right? So from here to here is 3 feet. And we also know that this thing is traveling at 100 feet per second. Right? And so the question, though, is, will this ball hit the fence? Will it hit before, or like will it clear it? Because that's what we're trying to find right here. So what's really neat is that they give us a function right here, and what this function represents. Okay, look here. This function represents how this ball travels. So this ball travels using this equation right here. Okay, and let's think about this. What does x represent? It told us in the problem. Let's see here. It says where x are measured in feet, meaning these are our feet right here. Okay, so if we think about this, we want to know, where is this ball going to be at after 300 feet, right? Will the ball be 20 feet above the ground, 9 feet above the ground? Because depending on how many feet it is from the ground, we're going to be able to tell if it's going to be able to clear a 10-foot thing. So basically, I want to let my x equal 300 feet. Okay, I'm going to plug in, I'm going to find f of 300, because this represents the path that the ball is on. So here, so at 300 feet, where is this ball at? Okay, and this is going to give us our height right here. So if I plug in 300, it's going to tell us where the ball is at. So let's go ahead and plug in 300 here. So negative 0.0032 times 300 squared plus 300 plus 3. Okay, so that calls for some mathematical calculation on our calculator. Let's see, we got to do all that. So we'll do all negative 0.32 times that by 300 and raise that to the power of 2. Let's see, simplify that. So go ahead and try this yourself. So this whole thing, if you put it all in your calculator, should just be 15 feet then. All right? So pause it real quick and make sure that you get that. So that means at 300 feet, the ball is somewhere like right here. Okay, right here. It's 15 feet. Do you think the ball at 15 feet is going to clear a 10-foot wall? The answer is yes, right? So the answer that they're looking for is, will the baseball clear a 10-foot fence located at 300 feet? The answer is C. Answer is yes, right? Yes, of course it's going to do it right there because we can see that right there. Another way that you could have approached this problem is to do this graphically. And basically, if you do this right here, if you actually, let me just go ahead and start a graphing right now. So let me just go ahead and move this guy down here. There we go. And let's go ahead and zoom right here as this thing's trying to focus. All right, so watch this. If you graph this, let's go ahead and graph this guy right here where it says -0 points. Oh, sorry. Let me try that again. -0.0032x squared plus x plus 3. If you try graphing that guy, as you can see here, you're like, what the heck is that right there? So what you may want to do is actually zoom out, or in this case, I'm going to just go ahead and just do a window, and I'm just going to kind of zoom out a lot here and look at my window range. I'm maybe going to go to the right, maybe at about more than 300, right? Because our x value was 300, so maybe I'm going to go to about 350. And maybe my height on my y scale, I don't know, maybe, I'm sorry, I'm doing the y max. I want to go x max 350. Maybe like we'll go as high as, I don't know, 20 feet. Let's see what that gives us. Okay, so as you can see here, our ball went, so it's way up here, and then it's coming down now. So it goes a lot higher than 15 feet, right? I mean, our ball was high in the air, so maybe I'll go up a lot more. So maybe I'll go on my y scale, and I don't know, maybe we'll make it 500 feet. Oh, I went way too much now. So now we're, okay, let me cut that back maybe to like, I don't know, maybe like 100. Okay, so let me check that out real quick. All right, so a little phone call there. I had to pause the video. All right, so maybe we'll make our y scale, I don't know, more like 200 or or something like that. So let's just make it 200 so it looks a little better. And graph that. Okay, that makes a little more sense. Okay, so here's the batter. Hits the ball. So we want to know what happens when we are at the, where's the ball at 300, right? So maybe it's about somewhere over here. Maybe like this is like 300, right? We want to know what's the height of it, because we wanted this to be bigger than 10 feet, right? So what I'm showing you right now is you can actually solve this graphically, meaning use the trace button and see what happens when you're at 300 feet. Actually, let's use the calculate. Press second, calculate. Second, calculate. And what happens when our value, we're going to plug in right here, 300. So plug in 300. Oops. And look at right here. Wait, no. Okay, so my approximation was a little off right there. So this is erase that. So that means, look, right here is 300. And if you look at the y value, oh, you're at 15 feet. Oh, so that means that our ball will clear a 10-foot wall at 15 feet. So this is another approach. You could have done it graphically and to find the same answer and say, oh, yeah, it's 15 feet. And the answer is C.